Hello student, I'm Mr. Leung. So in this video, I'm going to talk about the questions of respiration. Just like the chapter of photosynthesis, there are so many questions of experiment in this chapter. So before I go through the question, I would like to talk about the common chemicals used in the experiments of photosynthesis and respiration. So the first group of chemicals, we have sodium hydroxide, potassium hydroxide, and soda lime. All of them, they are alkali, and they can absorb carbon dioxide. And for the soda lime, they are in the petlate form. And for the sodium hydroxide and potassium hydroxide, they can be either solution or petlate form. But when do we decide to use the liquid form or the solid form? It depends on the orientation of the test tube. If we place the test tube in horizontally, so you can see that we place the germinating seed here and place the soda lime, the petlate form, okay, in the test tube. And we are going to investigate the respiration of the germinating seed. So imagine that if we do not use the soda lime, but use the sodium hydroxide and potassium hydroxide solution, okay, so what will be the problem? The solution, they may move and soak the germinating seed, okay? So when the alkali come in contact with the germinating seed, so it will damage the seed. So later on, we shall not have any result to be observed. So, and the other group, we have the anhydrous calcium chloride is going to absorb the water, absorb the moisture. And for the sodium hydrogen carbonate solution and sodium hydrogen carbonate indicator solution, remember that we talked about in lesson already. So for the solution, it can release carbon dioxide. But for the indicator, is responsible for testing the concentration of the carbon dioxide. They are totally different. And for the sodium hydrogen carbonate indicator solution, we have another type of solution to compare with it. We have lime water. So remember that the function of these two solutions are also different. For the indicator solution, we can use it to test the carbon dioxide concentration. But for the lime water, we use it to test the presence or absence of the carbon dioxide. So remember the results, the color changes, okay? When the carbon dioxide concentration is equal to 0.003%, so the color is red, okay? Higher than 0.
咁樣轉到即刻學見到啦，緊機，好辛苦。
0.03, okay, is yellow, and lower than that percentage, it will become purple. So remember that the question will not tell you these changes, okay? You need to memorize it before you enter the examination hall. And also the lime water, okay? Presence of carbon dioxide, it becomes milky white. And absent is colorless. It remains colorless. So remember that once we talk about the changes or the result of the test, you need to talk about if the carbon dioxide is present. You need to talk about the lime water will change from colorless to milky white, but not just tell me, oh, the lime water will become milky white. Okay, I don't know what is the original color of lime water. Sorry. So you need to tell me the changes. Okay. So we go to the questions. So for question 2 and 3 is talking about this setup to investigate the respiration. So these little worms, okay, the little bugs. So in the experiment, okay, in the setup, at the very beginning, the liquid level of both sides of the setup, okay, they are the same. Okay, so that means the air pressure on both sides, okay, they are the same. So that's why the liquid level are also the same. And for this setup and for the questions, I want you to recall the function of the potassium hydroxide absorb carbon dioxide as I mentioned. Okay, and also recall the gases involved in the respiration. Okay, the question already told you that it's talking about respiration. But of course, okay, you know that in some questions they hid, okay, they make the word hidden, okay, and then they need you to think about that. Or is the question talking about respiration, or is the question is talking about photosynthesis? Okay, but at least you know that for the worms, they cannot perform photosynthesis, so they must be respiration, right? So oxygen is consumed and carbon dioxide is produced. And remember, we have potassium hydroxide in the boiling tube, so that means the carbon dioxide will be absorbed in the potassium hydroxide solution later on. And then that's why I want you to think about that on both sides, okay, this boiling tube and this boiling tube, okay, you need to think about the change of the air volume and air pressure in the boiling tubes on both sides. Okay, remember that oxygen consumed but carbon dioxide produced, so probably the air volume should not be changed. But the potassium hydroxide solution, it can absorb the carbon dioxide. So you need to tell me that, okay, the air volume in this boiling tube increases, decreases, or remain unchanged. You tell me. So we talk about the questions. For question 2, after 30 minutes, the liquid level of X was higher than that of Y. So that means the new liquid level will be here, okay, and the new liquid level will be here. Okay, so what do you think about is about the air pressure on both sides. Okay, most probably that means this boiling tube, okay, the air pressure is higher than this boiling tube, so that means the higher air pressure will push the liquid level, okay, downwards, and then this liquid level will rise. Okay, so that's basic concept here. So what will be the possible reason, okay, or the amount of heat given out, oxygen absorbed, water vapor released, and carbon dioxide produced? So according to the reaction, you know that oxygen is really consumed, absorbed, carbon dioxide is really produced, but remember that the potassium hydroxide will absorb the carbon dioxide, and then water is released and energy is released, okay, maybe in ATP form and in heat form. But remember that for the whole question, we are talking about the air volume and air pressure. So I think you can get the correct answer. Okay, so for question 3, it's talking about if we withdraw, okay, the gas from the syringe, so and then test the presence of carbon dioxide. So which combination will be correct? So remember that what we are going to talk about is the air composition, the presence of carbon dioxide. I'm not talking about the concentration. So you should know that the answer should be either A or B. Okay, C, D must be wrong because hydrogen carbonate indicator is to test the concentration of the carbon dioxide. Okay, so it must be A or B. But what is the result? Okay, so my hint is that think about potassium hydroxide. So for question 4, it's going to investigate the anaerobic respiration of the yeast by the following setup. Okay, and in order to investigate whether carbon dioxide is produced by the mixture, so which is the correct modification we need to do. So according to the equation, carbon dioxide, they must be produced. But this question is asking, by using the setup, how can we confirm that carbon dioxide is really produced? Okay, so for the option A, adding a cotton wool, okay, as the heat insulator of the flask. But remember that our target is not heat, our target is carbon dioxide, so A is wrong. And then for B, immerse tube X into lime water. Now lime water, what is the function? You tell me, okay? But for the tube X, you should know that, okay? For the answer is it suggests that we need to put the tube X in the lime water. Okay, so I enlarge the diagram a bit. Okay, remember this diagram, we talked about it in chapter 7 before. Okay, if the tube is immersed in the water or any liquid, okay, so actually it means the air will go into the liquid by this tube. And if the tube, okay, is above the solution, that means the air is out from here. Okay, so remember that if for this tube, imagine the case, we put the tube in the liquid and then we try to draw the liquid, okay, from this tube. Actually we are drinking the water, right? Okay, so when the tube is immersed in the liquid, so it must be air in, and the tube, okay, above the liquid, it must be air out. Okay, so that means option B is also wrong. Okay, so for option C, okay, it's talking about pull the tube wide so that it's above the oil layer. So remember that we are going to transfer the air, the gas produced from the right hand side to the left hand side. So that means there must be a tube to let the air go from this tube along the tube to the left hand side. Okay, and for D, add a layer of oil to the top of the lime water. That means add the oil here. So what is the use of the oil layer? Actually, the function is to block, to prevent the oxygen to dissolve in the solution. Remember that we are going to investigate the anaerobic respiration, but not aerobic. Okay, so for question 6, okay, it's about the comparison between the alcoholic fermentation and lactic acid fermentation. That the equation is shown here, and then the paragraph. Okay, I need to go through a bit. So for the option A, alcoholic fermentation produce carbon dioxide. Agree, absolutely, right? Okay, so for the alcoholic fermentation, it use the alcohol as the substrate, but according to the equation, you should know that it's the product instead of substrate, right? And then the byproduct will be further metabolized. That means maybe the yeast, maybe the plant, okay, they can deal with, they can handle the alcohol after they are made, they are produced. Oh, but actually you should see that the alcohol, once they are produced, okay, they are just maybe released, okay, they might just stay in the cell, something like this. Okay, so actually will be further metabolized is wrong. And alcoholic fermentation, it occurs in plants only. Okay, so you can see from the first sentence, yeast can also undergo alcoholic fermentation. Okay, so not plants only. But for the plant, I would like to highlight that the seed and the root cells of some plant, if they are in the waterlogged soil. Waterlogged soil, that means they are full of water, so much water. So that means the air, especially the oxygen level, is very, very low. Okay, so that's why the seed, that's why the root cells, they need to undergo the anaerobic respiration, okay, to get some energy. So for the lactic acid fermentation, okay, just according to the equation, you should see that, oh, lactic acid fermentation does not produce carbon dioxide. That's correct. Okay, do they use the lactic acid as the substrate? Of course not, because lactic acid, they are the product. And for C, byproduct will not be further metabolized is definitely wrong, because we can deal with the lactic acid. Remember that after doing rigorous exercise, we keep panting fastly, deeply, okay, because we would like to intake extra oxygen, and the extra oxygen will be used to break down the lactic acid or convert it into glycogen in liver. Okay, and then the last one, of course, in animal only, of course not, because the anaerobic bacteria, they can also carry out lactic acid fermentation. So we move on to question 9. So in this setup, we can also see this little box here, and also we have 4 flasks. So flask A, B, C, D. Flask A containing sodium hydroxide to absorb carbon dioxide. Flask B and D contain lime water, and flask C, there are the box here. So for the concept, okay, remember, recall the function of the chemical used in the experiment. and then identify the air composition in each phase. For example, for phase A, when the air go in, so the carbon dioxide will be absorbed by the sodium hydroxide, and then the air will go from phase A to phase B. Okay, so probably in phase B, supposedly there should no be carbon dioxide. Okay, so that's why I want you to identify. And after the air pass through the box, okay, so what will be the air composition in phase D? Okay, and then we call the gas produced by the respiration. Obviously, this experiment is talking about respiration. Of course, not photosynthesis. You should know it. Okay. So, one more thing I would like to talk about for this question is about the tubes again. Okay, which side is air in and air out? According to last MC, we talk about that once the tube is immersed in the solution, actually it must be air in, and if the tube, okay, is above the liquid, okay, it must be air out. So for this question, it's very good because it already told you the air in here and air out here. So that means air in A, out of A, in B, out of B, in C, and out of C, and in D, and out of D. Okay, so for the question, okay, it's very good. It told you, but some questions, okay, it may not tell you. So it may just leave these two parts to be blank and ask you which part should be air in and which part should be air out. Okay, or some question they may even reverse the direction. On the right hand side air in and the left hand side air out, and then ask you what is going wrong. How can you modify the setup to make it can become functional again? Okay, so remember that. Okay, the tube immersed in the liquid, air in. Above the liquid, air out. Okay, so go to the question. Question A. What is the purpose of phase B? Okay, the second one. Okay, just next to the phase A, containing the sodium hydroxide to absorb carbon dioxide. So for part A, don't tell me the function of lime mortar. I'm not asking about that. I'm asking what is the function of the phase B. Why we need to have this phase in the whole setup. Okay, phase A, absorb carbon dioxide. Okay, I agree. And then pass to the box, and then pass to phase D. Okay, to check that any gases is produced by the box, right? Okay, but what is the purpose of setting phase B? Okay, and for B, what change would you expect in the lime mortar in phase D? Okay, now remember, if there is really the change of the lime mortar, okay, tell me the color from something something to something something. I need the change from A to B. Okay, but don't just tell me, oh, the result will be B. Okay, what is the result will be B? Or what is the original color? You need to tell me. Or you may say that no, there will be no change, Mr. Leung. Okay, so can you just write down remain unchanged? Sorry, I don't know what is the meaning of unchanged, but I know the original color. So if you know the original color of the solution, okay, tell me it remains the original color. Remain do, okay, but not just remain unchanged. I don't know what it is. Okay, being a science student, be specific. Okay, so for the part C, name the process being investigated. So for the bugs, okay, what do they do? Okay, what do they carry out for the bugs? Okay, and then for D, what substance is broken down by the bugs? Okay, during the process. That means during that process it mentioned in C. Okay, so you should know the answer. And part E, name one way the bugs will use the energy released by the process. Okay, so it's obviously any process can release energy. And what chapter you are studying now? Okay, so you need to recall any activity, okay, in the organism. It requires energy. And for the last question, question 13 is about the matching. Okay, we have glycolysis, Krebs cycle, oxidative phosphorylation, and photosynthesis. So the first part, you need to distinguish the process of photosynthesis from those of respiration. Okay, obviously we have only one photosynthesis here. And of course, some questions, okay, they may not only give you one photosynthesis. They may give you the other cycle, or Kelvin cycle, or photophosphorylation, and give you all the terms together, okay, for you to distinguish, for you to identify. So that means you need to do revision and become able to distinguish those processes from each other. Okay, and for the second one is that I want you to identify which process will produce hydrogen atom, and the hydrogen atom will be carried by the hydrogen carrier. Okay, so you can see the NADP, something like this. Okay, now remember, they are the hydrogen carrier. NAD and NADP, they are the hydrogen carrier. But okay, which one is taking part in the photosynthesis and which one is taking part in the respiration? You need to tell me, because you are going to do the matching, okay, for respiration and photosynthesis process. And the last one is that we need to identify which process will receive the hydrogen atom from the reducing agent. Then the hydrogen carrier is regenerated. Now remember that. Okay, for no matter respiration and photosynthesis, okay, we have those hydrogen carrier, and they must be regenerated. Otherwise, okay, all the hydrogen carrier, they receive the hydrogen, all of them are occupied. So no more hydrogen carrier, okay, can uptake, okay, or receive the hydrogen. Okay, so remember those 3 key questions for you to think about the matching. So if you have any question, please leave your question in the message box. I will answer you as soon as possible. Bye bye.